In this lesson, we're going to do some examples with simplifying expressions with exponents. Now, when I do this, there's a lot of different ways to do this, but I kind of have a consistent process that I do. As you go, we'll kind of see as these problems develop, but I like to take care of the parentheses first and then get rid of all parentheses. Once I get rid of parentheses, I can start rearranging and moving pieces, which especially I'm going to be looking at my negative exponents because negative exponents are just going to move, so I'm going to need to rearrange. Once I'm done rearranging things, I should have nothing but positive exponents. So here I'm at the point where I can combine my like terms by adding some exponents together and or canceling by subtracting some of my exponents together. So let's take a look. So for the first one, directions are going to say simplify, and we'll take x squared y cubed to the fourth times 2x y to the third squared. So we got to remember our properties, and the first thing I'm going to take care of is I have parentheses, so I'm going to eliminate the parentheses, and this is where you're going to have powers to powers. So this fourth power is going to apply to everything in here, the second power is going to apply to everything here. So powers to powers, we're going to multiply this together. So x to the 8th, y to the 12th. That piece is going to be multiplied to this one. Everything gets an exponent, so if that throws you off, by all means, let's add exponents to everything so we can see that everything is going to get an exponent applied to it. So this will be 2 to the second, x to the second, y to the 6th, because a power times a power will multiply. Now we just have like terms to put together. The 2 to the second isn't going to be able to multiply with anything else, so that's just going to be 4. The x's, we have 8 here, we have 2 here, so that's where we're going to add the exponents together. That's going to be x to the 10th. And then the y values, we have 6 here and we have 12 here. That's going to get y to the 18th. Alright, so first thing, we took care of parentheses, we didn't have any negative exponents, and we just combined our like terms. So second problem. A little bit more complicated. So x to the negative 2 times y to the 4th over x to the 5th y to the 6th times 4z to the negative 3rd x to the 4th over 8y x to the negative 2. Alright, so the order to this is I'm going to start off by, do I have any parentheses? Do I have anything where I have to apply that exponent to everything? No, no parentheses. So second thing is I'm going to start looking at negative exponents. Anything with a negative exponent, I'm going to just move it. So I like to make them stand out, because all that's going to happen is they're going to move. That one's on top of the fraction, is going to move to the bottom. So from the numerator to the denominator, this one's going to move down, and this one's going to move up. That's all that negative exponents, that's all I have to do to take care of negative exponents. So what's that going to look like? So for this fraction, we'll have y to the 4th on top. This will come down, so that'll become a positive x to the positive 2, rather than leaving it as a negative 2. And then we have the x to the 5th and the y to the 6th, they don't go anywhere. Over here, we have the 4. It doesn't have a negative exponent on it, just the z does, so that'll come down. The x to the 4th is going to stay. Alright, so we'll bring down that z to the 3rd. So we already have a y, an 8. We have a y. This will come down, so that'll be a z to the positive 3. And this piece will come up, making it an x to the positive 2. Now, we're done with negative exponents. Let's see if we can combine any like terms. So we'll combine straight across, so top times top, bottom times bottom. So we'll have 4 x to the 6th, and there aren't any more y's on the top. Divided by 8, there's no other numbers to multiply with. We have 7 x's, we don't have any more. So x to the 7th, and if this helps, we can put a 1 on this to know that that's 1y, and we're going to combine it with the 6 y's. That'll make y to the 7th, and there aren't any more z's, so the z to the 3rd. So the last step is we've combined everything. Now we're going to look to cancel. Do we have x's on top that can cancel with x's on bottom, y's on top, y's on bottom, and then even the numbers. So I'm going to start with the numbers because the math is a little bit different with the numbers than they are the exponents. So this is as if this fraction didn't exist, or all these variables didn't exist, and I'm just reducing 4/8, and 4 goes into both of them. 4 goes into 4 one time, 4 goes into 8 two times. All right, and then I can start canceling. So I have, again, I look at this a little bit different where do I have more x's? I have more x's on the bottom by 1, so 6 of those are going to cancel 6 of those and leave me with 1. So I'll have a 2x on the bottom. And then I have more y's on the bottom by 3. So 4 of those will cancel 4 of those, leave me with 3. Y to the third. And then we don't have any z's to cancel at all, so we'll just rewrite that. Now we can't have nothing on top because when you reduce all of these pieces, they all technically become 1s. So 1 times 1 times 1 will just be a 1. All right? So let's do another one. So if we have, parenthesis, 2x to the negative 4, y to the 5th, over x to the negative 2, y to the negative 3, all raised to a negative 2. And again, there's a lot of different ways to do this, but I'm going to follow these steps where I'm going to start with parentheses. I'm going to deal with my negative exponents. I'll combine anything I can combine on top, and then I can start to reduce and see what where I have more. So first thing is we'll take care of the parentheses, and there's a lot of ways to do this, but this is just kind of how I approach it. So I'm going to apply this to every single piece, and I'm going to give the 2 an exponent just to make sure I realize that that 2 is going to get that exponent as well. So that's going to be a 2 to the negative 2. Now here all of these are going to be powers to powers, so I have a negative 4 times a negative 2, which becomes a positive 8. The y's will become a negative 10, and then in the denominator, negative 2 and negative 2 will make a positive 4, and the y's will make a positive 6. So done with parentheses. I'm looking at negative exponents. So anything that I have with a negative exponent, I circle it. I like to make it stand out, because all that's going to happen is it's going to move. If it's on the top, it's going to move down. Nothing else is going to change. So that'll leave us with x to the 8th on top. This 2 will come down, and that negative power will become a positive power. These already had positive powers, so they'll stay. And then this y to the 10th will come down. All right, so now I'm looking to combine and cancel some things. So I notice that I don't have any more x's to combine, but I do have more x's on top than I do on the bottom. So that's going to leave me with x to the 4th. And 4 of these are going to cancel 4 of those. Leave me with 4 on top. And then 2 squared is 4. And we'll combine our y's together, and that'll be y to the 16th. All right. Another problem. A little bit different, but still involves properties of powers. This one. You have what we call a binomial times a binomial. There's 2 terms times another 2 terms. And this is a distribution problem. You may have also heard it as FOIL. FOIL just kind of helps to organize everything. But basically this 2x is going to distribute to the x and the 3. So we'll multiply 2x times x, 2x squared, 2x times x, 2x times 3, and it's a positive 3. So plus 6x. And then the negative 1 is going to distribute to both. And so that's going to be a negative 1 times x is negative x. Negative 1 times 3 is negative 3. And we have like terms to put together. Now we're not dealing with exponents, we're dealing with like terms, so now it's coefficients that are going to go together. And those are like terms, so the 2x squared doesn't have another like term, so that's just 2x squared. 6 minus 1, if you need to write a 1 in front of that. 6 minus 1 is 5, so it's a plus 5x minus 3. So you got to shift gears a little bit, where exponents, you're adding the exponents together, and then here when you're subtracting or you're combining like terms, here it's the coefficients that you're combining. All right, one more. So what about, this one has a tendency to stump people a lot. This problem right here. Very similar to this, where it seems like we should just be able to apply that exponent into everything, but unfortunately exponents do not distribute over addition and subtraction. So if you have an x plus 5 or an x minus 5, if there is addition or subtraction at all involved, that property that we did up here, it's not going to work. So there's no addition or subtraction, so we can apply to everything. So this does not equal x squared plus 25. You don't just square the pieces. It does not equal that. So what you have to do is, the whole idea of a square means there's two of the exact same things multiplied together. So very similar to this, we're going to be doing distribution. So x times x and x times 5. So x squared plus 5x, and then distribute the 5 to both. So 5 times x is another 5x, and 5 times 5 is 25. And you have like terms, so we'll combine those together. So we'll add the coefficients together, which will make 10x plus 25. Now, if you look at this answer, yeah, there's definitely a pattern that's happening. There's no coincidence at all that if you take these two and multiply them together and double it, you're always going to get that middle term. And it's because when you distribute everything together, you're always going to have those two pieces, those two like terms that are identical to each other. So if that's a 3, then you'd have a 3x and a 3x, and that would make a 6x. And it's also not a coincidence that you're going to get that piece squared, which seems like, you know, this works, but if you just think that this distributes in, you'll always miss your middle term. So unfortunately, there's no other way around it. You have to write it out twice and combine all your like terms after your distribution. And that was simplifying some expressions with exponents.